Hey everyone, and welcome back to The Explainer. Today, we are taking a fascinating journey down to the microscopic level. Actually, scratch that, even smaller than that. We are entering the nanoscale. Okay, let's dive into this incredibly intricate world. We're going to break down a really comprehensive visual map that categorizes these tiny, highly engineered structures known as nanoparticles. These invisible workhorses are quietly revolutionizing everything from medicine to material science, and by the end of our time together today, you'll have a crystal clear understanding of exactly what they are and how they differ from one another. To make this dense map easy to digest, we're going to explore 5 distinct areas. First, the overall nanoparticle universe. 2. Biological and organic carriers. 3. Polymers and quantum dots. 4. Metals and minerals. And finally, 5. The toolkit's potential. All right, kicking things off with Section 1, the nanoparticle universe. Let's get a bird's eye view. Now, what's really interesting about this map is just the sheer variety. It's striking. Radiating outward from that massive textured blue hub right in the center are 8 completely distinct categories of nanoparticles. Each one has its own unique geometry, its own specific building blocks, and of course, its own specialized function. This infographic basically acts as a complete roadmap to the nanoscale, organizing all that chaos into perfectly logical families. But before we look at those outer branches, we really need to focus on that giant central blueprint. This central image is kind of our conceptual anchor. What you're seeing is a large spherical core, right? It's densely packed and textured, but more importantly, it's heavily equipped with those functional pink U-shaped surface receptors. Those receptors are absolutely crucial. They represent how a nanoparticle interacts with its environment, acting almost like keys looking for very specific biological locks. It's the structural foundation for everything we're about to discuss. A core payload area surrounded by a highly interactive surface. Moving right along to Section 2, biological and organic carriers. Let's see some organic traits in action. Starting up with the protein-based nanoparticles, these are perhaps the most organic-looking of the whole bunch. They're represented as these rather simplistic clusters of small orange spheres. But notice those cyclical arrows wrapping around and linking them together? That beautifully illustrates their dynamic nature. They aren't just static rocks. They're active, interacting protein structures that cluster together to form a functional unit. Now, just below the proteins, we find something far more structured, lipid nanoparticles. This is a complex, multi-layered vehicle. If you look closely at that boundary, it's not just made of one material. It's a highly engineered ring composed of ionizable cationic lipids, pegylated lipids, phospholipids, and sterile lipids. All of these different fat molecules are working in unison to create a protective, customizable shell. And what exactly are they protecting? Right there in the center, we see the squiggly lines clearly labeled as drug cargo. It's literally a microscopic safe designed to transport delicate medicine. It's super fascinating to contrast these organic structures. Think back to those simple, clumped orange spheres of the protein-based nanoparticles. Now, look over to the top right at the exosome-mimetic nanoparticles. These guys are actually mimicking the natural exosomes our own cells use to communicate. So instead of a simple cluster, we see a highly intricate, biologically inspired bilayer, that yellow and blue double-walled boundary encasing the inner structures. It perfectly highlights the difference between naturally clustering proteins and a highly engineered synthetic boundary designed to mimic complex biology. Okay, on to Section 3, polymers and quantum dots. Time for some really complex engineering. Down in the bottom left, we've got the polymeric nanoparticles, and the visual representation here is just brilliant. Inside a thin spherical boundary, you see this tangled, almost spaghetti-like web of blue lines. These are the polymers. And suspended within that tangled blue net are specific pink spheres, once again explicitly labeled as drugs. So rather than a hollow shell like the lipid nanoparticle we saw earlier, this is a web-like matrix specifically designed to hold and eventually release its therapeutic payload. Let's see how this concept builds into the most structurally complex particle on our entire map, the quantum dots, or QDs, located on the right side. This diagram is a masterpiece of layering. Starting from the very center, we have the primary quantum dot core. That core is immediately encased in a shell. Surrounding that shell is an amphiphilic polymer, which is then further modified by hydrophobic surface ligands. But it doesn't stop there. Attached to the very outside of this incredibly complex sphere is a whole array of functional tools: proteins, Y-shaped antibodies, general drugs, and specific hydrophobic drugs. It is basically the Swiss Army knife of the nanoscale world. So, the crucial point here is this recurring theme we keep seeing across the infographic. Whether we are looking at the hollow shell of the lipid NPs, the tangled web of the polymeric NPs, or the dense, multi-layered surface of those quantum dots, the source explicitly labels them as carrying drug cargo or drugs. This map isn't just showing us a bunch of tiny shapes. It's showing us an entire fleet of highly specialized, microscopic delivery vehicles engineered to transport medicine. That brings us to Section 4, Metals and Minerals. Let's look at some elemental structures. Here we find the metallic nanoparticles. And honestly, after the sheer complexity of the quantum dots and lipid vehicles, the visual translation here is starkly simple. We just see a densely packed, tightly unified cluster of golden spheres. There's no hollow core, no tangled web, no intricate layering. It is a solid, uniform, geometric clump of pure metallic material. It represents a fundamentally different approach to nanotechnology that relies on the unique properties of metals at this tiny scale. We can also compare the mineral-based structures. Check out these silicon nanoparticles at the bottom, which consist of large blue silicon spheres bonded with smaller pink oxygen spheres. Now contrast that with the inorganic nanoparticles at the top right. They also rely on oxygen, depicted as those black spheres, but they pair it with cerium ions, specifically C3+ and C4+, shown as yellow spheres. So both utilize oxygen to form their structures, but by pairing it with completely different foundational elements, they create entirely distinct types of nanoparticles. Finally, Section 5, the tiny toolkit's potential. Let's zoom back out and look at the infographic as a whole one last time. And this brilliantly illustrates the true power of nanotechnology. We aren't just looking at one single solution here. We're looking at a unified toolkit. You have your elemental clumps like the metallic and silica particles, organic actors like the proteins, and highly engineered multi-layer delivery systems like the liposomes and quantum dots. Each of these 8 distinct families offers completely different physical and chemical properties for scientists and researchers to play with. When you step back and realize that we now have the ability to engineer matter at this level, literally designing specific lipid shells to protect delicate drugs or layering quantum dots with exact antibodies, it really makes you wonder, how will this incredibly diverse, tiny toolkit reshape our future? From targeted medicine to next-generation materials, the possibilities locked inside these tiny spheres are practically limitless. Thank you so much for joining me on this deep dive into the nanoscale here on The Explainer. Keep exploring, and I'll catch you next time.